let's go ahead and do notes 14.4. Hope you had fun yesterday with Euler's method. 14.4, it's going to start out with a little bit of review. Absolute value of 3 means that y could be 3 or it could even be negative 3. Reminder, when we look at y squared equal 9, y could have been 3 or could have been negative 3. We're going to use some of those facts that we're going to go over here later on in our application. So let's just kind of bring back some good memories to help us. Some log laws that might come into play. E raised to the natural log of x is just plain old x. And then when we have like bases multiplied together, we're going to add the exponents m and n. Dividing by the number is the same thing as multiplying by its reciprocal. We use this fact several times in the next set of problems. Solution to a differential equation are functions. And sometimes some things that aren't functions but just relations. They don't necessarily have to be just functions. We sketch solutions to differential equations using our slope fields, those little tick marks that kind of show us the direction that we're going in each one of those. We have done a little bit of solving differential equations, and the method we're going to look at today is the second method called separation of variables. In 14.1, you did a bunch of problems using antiderivatives. We can also do this using something called separation of variables. Sometimes we might be able to separate our variables, separate the variables, get all the x's on one side, get all the y terms on the other side. We do this using only multiplication. Words, buddy, division. Okay. We're only going to separate our variables by multiplying or dividing. You may be able to change an addition problem or a subtraction problem to a multiplication problem by using factors or factoring. Okay. Let's look at some equations that could be, that are definitely separable. You'll see that we've got a dy dx on this side, and we've got an x and y on this side. If we multiply both sides by dx, divide both sides by y, we'll get 1 over y dy equals x dx. Something we did a long time ago when we did some implicit differentiation. Okay? Let's take a look at this next one. Same thing here. We could separate, get our y's on one side, multiply both sides by y, divide both sides, multiply both sides by dx. This will give us y dy equals sine of x dx. Okay? Or just plain old cross multiplying here. And it gave us the cross products. The next one, we can divide both sides by y and multiply both sides by dx. And this will give us the inverse of y dy equals 1 over cosine of x dx, or 1 over y, let me write it that way, 1 over y dy equals, another way of writing 1 over cosine would be the secant of x dx. Those are separable. Let's look at these guys down below. These are not separable. If we subtracted y from both sides, this will give us dy dx minus y equals x. Multiplying by dx gives us a problem here. Gets rid of the dx here and moves it over there, but we still have to multiply this guy by dx. Now, if we moved it over here, we're moving the y over. If we keep it there, we keep an x there. Inseparable. Next one. No way. These can't get out. There's no way you can get the x and y out of this sign. So we can't get them apart. And this one, oh gee, we got a big mess on our hands on this one. With all that's going on inside of this radical there. Yeah, we could move the dy, we could move the x, but this thing is going to give us a big trouble. So some are separable and some are not separable. We're only going to deal with the ones that are separable. Okay? So here's some steps that we're going to follow. In separating variables, change any problem to multiplication problem if it isn't already. Separate the variables, and then we're just going to integrate both sides. Can you see where not a bad job here of being able to integrate this? We can take the integral of 1 over y. We can take the integral of 1 over x. Boom. We're good. Then there may be a little bit of manipulating we'll do to get y by itself. That'll be solving for y. And now this is very important. Okay? This gives, I see more problems lost or points lost on the test because of failure to do this than anything else on separation of variables. Seems to flow, it's easy, but if you're given an initial condition, make sure you're putting that back in to the initial equation and your final solution to make sure that both of those are going to be true. Okay, you've got to have it. If it's not given, hey, no big deal. There's just nothing for you to check. You're going to have some value of C. All right, let's go ahead and do these. I'm going to use a separate sheet of paper and strongly urge you to do the same as we work through these. So problem number 12. It says, let's go ahead and solve this by separation of variables. We have dy dx equals the square root of x y. Dy dx then would equal the square root of x times the square root of y. Inside times inside, outside times outside. We can reverse that, which makes this pretty easy to separate. We can divide, multiply. This would end up giving us y to the negative 1/2 dy, and of course x to the 1/2 dx. If we integrate both sides, we're going to get closer to solving for y. All right, so remember, add 1 to our exponent, do that first. This will give us 1/2, multiply by that reciprocal. This will give us 2, equals 1 added to this will give us 3/2, multiplied by the reciprocal, which will give us 2/3, plus c. I want to point out there's no need to do a c over here and a c over here because it's some constant. Whether this was 7 and this was 3, you'd subtract and get the value of negative 4 over here. So it doesn't matter that we have just one constant. We have to have a constant to get this correct, but we're just going to put it over here on the side with x because we know we're trying to solve this differential equation. We want to get y by itself, so let's just get the c over here. If we ended up with a c here first, then we would have subtracted and gotten another c anyway. Okay? And I'm just as a habit going to start by saying this one's c1 because there could be more than one c as we manipulate through. And you can see that our first step to getting y by itself is going ahead and dividing everything by 2. This will give us y to the 1/2. Half of 2/3 is just plain 1/3. And of course this will remain x to the 3/2. And then just write c2. There's no need to write c divided by 2. We don't care what constant that is. We'll get to some constant eventually. Okay? So one more step, of course, to solve for y. We've got to get rid of this square root symbol. We do that by squaring both sides. Y equals, just put the whole thing in, parentheses, squared. 1/3 of x to the 3/2 plus this c value, which now I'm just going to put as plain old c. They don't care whether it's c1, c2, c3, c4, or whatever. I'm just going to put it as just some constant c, and that's my final answer. Let's move on to number 13. Number 13 starts out by saying that y prime equals e to the x plus y. Right? Remember, first step is change it to a multiplication problem. All right? So let's just rewrite d or y prime as dy dx so we know what that is. And we know that we can change this to a multiplication problem by saying this is e to the x times e to the y. Dividing and multiplying would give us e to the negative y dy equals e to the x dx. Let's go ahead and integrate both sides here to solve for y. We're trying to get y by itself here. Okay. This one will be e to the negative y. Of course, we have to change the sign of that. E to the x, just plain old e to the x, plus her buddy c1. Okay. Then, to get y by itself, let's get rid of this negative. So we'll multiply everything by negative 1 or divide by negative 1, doesn't matter to me. E to the negative y equals the opposite of e to the x, and then plus c2. I don't bother changing the sign there. This is going to be some constant. It's going to be a family of values. Just change it to c2. Don't worry about changing the sign there. All right? And then we do need to solve this to get y out of that exponent. We're going to take the natural log of both sides. So this will be the natural log of e to the negative y equals the natural log of negative e to the x plus our c2 value. And this we know just takes care of itself, gets rid of the e, and results in, keep your sign, negative y equals the natural log of the opposite of e to the x plus c2. All we have to do, multiply both sides by negative 1. Y equals the opposite of the natural log of negative e to the x plus, and again, like we've done before, let's just write it as our final c. And that's the solution to that differential equation. Find a solution to the differential equation. In 14, we've got this one, 2 sine of x minus y squared dy dx equals 0. Okay? We want to make this into some type of a multiplication problem. Let's go ahead, and I think it's going to be easier for us if we just add this to both sides, giving us the sine, 2 times the sine of x equals y squared dy dx. Next, let's get this dx out of the way. We've got only y's over here, but just that x, little extra dx. So this gives us 2 sine of x dx equals y squared dy. Let's go to integrating again to get our antiderivative, get rid of the dy's and the dx's when we do that. Of course, the antiderivative of sine is negative cosine. We'll just multiply by that constant, 2. Again, we want the y by itself, so let's put a c1 here. And then add 1, multiply by its reciprocal. And that'll give us y to the third. Multiply everything by 3, negative 6 cosine of x plus another c gives us y cubed. One more step. Y is just going to be the cube root of negative 6 cosine of x plus our buddy c. Okay? I do want to point out something to you that may not be the answer on the answer key. It may not be the answer on multiple choice. Every time you do these problems, I want you to keep going until it matches the answer key. Not use the answer key as just, okay, that's the answer and write it down, but use your math skills to get to that, or practice your math skills so when you get to the test, it's not so much of a struggle to get to these. This one's not so bad because the answer key could have been just all this to the 1/3 power, okay? Again, whatever matches the answer key is what you're going to keep working towards until you get. All right, let's take a look at number 15. Number 15 says dy dx equals x over y. Oops, I'm sorry, looking at the wrong problem. Looking at the next one down. Equals 2y plus 4. 2y plus 4. Okay. Now, I do want to change this to a multiplication problem to help simplify this a little bit. This is going to be 2 times y plus 2. Now you see I've got a nice multiplication problem. I can multiply both sides by dx, divide both sides by y plus 2, and this will give a 1 over y plus 2 dy equals 2 dx. Let's go ahead and integrate these. We end up with the natural log of the absolute value of y plus 2 equals, that's not so bad, just 2x plus our first constant, c1. Get rid of the natural log by taking both sides to e. So it will be e to the natural log of y plus 1, or excuse me, plus 2, absolute value of that, equals e to the 2x plus c1. And remember, we've done something like this before. We have solved implicit differentiation. We've done all this before. So this should come as no surprise for some of these steps. But again, it's good practice to get us back in the swing of things for the final AP exam. And we know that this e, raising this natural log to the power, or e to that power, gets rid of this natural log, so this just becomes the absolute value of y plus 2. And then that's going to equal, well, let's think about this. We know that this would be the same thing as e to the 2x times e to some first constant here. Well, this is just some crazy constant. Who cares what it is? So we'll just call that c2. This is just a constant. E to raised to a power is just some other constant. So rather than keep it messed up like this, we'll write it as c2 times e to the 2x. Absolute value means that this will be y plus 2 equals plus or minus c2 times e to the 2x. Then we'll subtract 2 from both sides, and this will give us y equals c, our final constant, e to the 2x minus 2. And you might ask, well, what happened to my plus and minus? Again, this is some crazy constant that's going to be found out when we put in some initial values. The positive and negative part of that will work itself out when we choose a value for x and we choose a value for y and solve for c. So no need to write this as negative c or plus and minus c. That's going to work itself out in the end. And that's our final answer. Okay? Let's take a look at our next problem. Next problem says not just solve this, but solve it given our initial conditions. Each one of these has a differential equation and initial conditions. So let's start with number 16, which says dy dx equals the cosine of x times e to the sine of x. Well, this one's not so bad because I only see x's over here. I don't see any y's. All I see is dx over here. All I need to do is multiply both sides by dx, and this will be dy equals the cosine of x e to the sine of x times dx. We can integrate both of these. And yeah, let's think about this. Isn't this kind of nice that we have the cosine here because that's the derivative of the inside? So left-hand side becomes y, and then this just becomes e to the sine of x. Remember, derivative of this, e to the x, or the sine of x, keep that, times the derivative of the inside. Derivative of the inside would be the derivative of the sine of x, which gives us cosine. So just reverse this derivative, find the antiderivative is that, and this will be plus c. In this case, I don't have to look at c1, c2, c3 because y's already solved for itself. But remember, we were given the initial conditions when x equals 0, y equals 0. So let's substitute those in. That's going to give us 0 for y when e to the sine of 0, and then add c to it. Of course, the sine of 0 is 0. Anything to the 0 power is 1, so this becomes 0 equals 1 plus c. So c is going to equal negative 1. So our equation will be y equals e to the sine of x minus 1. Don't forget what we said. You have to do this every time. Make sure that the initial value makes the final equation true. It has to work in this. It has to work up here. It has to work down here. Okay? So we have to be able to put in 0 for x and get some value here that makes sense. It can't make this wrong, nor this. Not a problem here. This is just going to be 1 times 1 and we get something. So there's not an issue with this. If, of course, we had something which gave us a 0 in the denominator, problem. Okay? But let's go ahead and check this based upon y sub 0 equals 0. It may not always work. In this case, we'll put in y equals 0. We'll put in 0 for x. And lo and behold, this one really works quite well because we get 0 equals 1 minus 1. 1 minus 1 equals 0. And it checks out okay. Let's move on to number 17. 17 gives us a differential equation that looks like this. dy dx equals x over y. And we're given the initial condition y sub 0 equals negative 2. Okay? Multiply both sides by y. Multiply both sides by dx, or cross multiply these. And this, that looks kind of nice. Y dy equals x dx. Add 1 to the power, multiply by the reciprocal. Add 1 to the power, multiply by the reciprocal. And then we got our little buddy c1 here. We can get rid of this half over here, which actually gets rid of the other one too. Oops, wait a second here. We're looking for c. Let's just go for it right now. We know when x equals 0, y equals negative 2. We can go ahead and substitute those right in here now and solve for c. Okay? We can either do it now or solve for y and solve, or get y by itself and then solve for c later. But I'm going to just go ahead and do it now. So again, we'll put negative 2 in here for y, because that was the initial condition. We'll put in 0 for x. That's pretty simple. That gives us 0 here. And that's going to equal c1. Negative 2 squared, of course, is 4. Half of that is 2. So C1 equals 2, and we can go ahead and continue with our solving for y, but now with a known value of C of 2. Multiply everything by 2. Y squared equals x squared plus 4. Take the square root of everything. Y equals plus or minus the square root of x squared plus 4. Okay? Now, again, do not forget to check. And let's put our initial conditions in. Y equals negative 2. And this will be plus or minus the square root of 0 for x plus 4. 0 squared is 0, plus 4 is 4. The square root of that is 2, but only the negative 2 is the one that satisfies our condition. So if we leave our answer like this, our answer will be wrong. Because based upon our initial condition, when x is 0, we should get negative 2. So the only solution to this one is going to be y equals the opposite of the square root of x squared plus 4. And now aren't you thankful that we checked our initial conditions to see if this equation was right? Sometimes it might be always wrong, and we say there is no solution. In this case, we just limit it to only the negative value coming out of that square root. All right, let's go back and look at our next one. Our next one is number 18. It starts out with dy dx equals negative 2y plus 6, and they give us initial condition of y sub 0, or y at 0 is going to give us 1. Okay? Again, don't get caught up with addition and subtraction here. We need to make a multiplication problem first. dy dx equals, let's factor out a negative 2. That'll clean things up maybe a little bit. Negative 2. And this will be a y minus 3. Dividing and multiplying will give us 1 over y minus 3 dy equals negative 2 times dx. Integrate, natural log of the absolute value of y minus 3 equals negative 2x plus rc. And same thing I did last time. I'm just going to jump right in here and solve this. Again, you could go further, but I'm just going to get him now. So we're going to put in 0 for x, which is nice because this is just going to become c on this side, and 1 for y. This will be the natural log of 1 minus 3, which will be negative 2, which means c equals the natural log of 2. The absolute value of negative 2 is 2. So we can continue on with this, with now knowing what c is. This will be the natural log of the absolute value of y minus 3 equals negative 2x plus the natural log of 2. Okay. We're going to raise everything to the power of e, which will leave just y minus 3 over here, and this will be e to the negative 2x plus the natural log of 2. Let's simplify this just a little bit. So the absolute value of y minus 3 equals e to the negative 2x times e to the natural log of 2. Of course, absolute value here can be gotten rid of by saying this is just going to be a plus or minus on this side of, well, think about this, e to the natural log of 2. Isn't that just 2? So this becomes 2 times e to the negative 2x. Add 3 to both sides. Y equals plus or minus 2 e to the negative 2x plus 3. we still need to do some checking here. So let's go ahead and substitute in our initial value, x equals 0, y equals 1. Let's go ahead and check here. So let's see, this will be 0 equals plus or minus 2, oops. I think I wanted to put 1 there, didn't I? Yeah, this should be 1. I'm putting in y equals 1 and x equals 0. So this would be e to the 0, which of course is 1. And that will give us 3. And yeah, let's think about this. If we want to get 1 out of this, the only one that's going to work is the negative 2, not the positive 3. So only negative 2 works in this one, which means this equation here is not true, but y equals negative 2 only times e to the negative 2x plus 3. That is our final answer. We have time to do number 19, so let's go ahead and move on to that one. This gives us dy dx equals y times the square root of x. And we're going to evaluate this one, kind of the same condition we had on the last one. When x equals 0, y equals 1. Okay, let's get our y out of the way, get the dx on the one side. This will be 1 over y dy equals x to the 1/2 dx. Let's get some integrating going on here. The natural log of the absolute value of y will equal, add 1, 3/2, multiply by the reciprocal, 2/3, plus our buddy c. Same thing, let's do some initial conditions here. We'll let y equal 1, and we'll let x equal 0. Of course, the natural log of 1 is just 0. Of course, that one again was just 0 for x, which means c is 0. So you can see a nice advantage of getting rid of c right away is sometimes, hey, c is just 0, or solving for c right away, we get rid of it because it's just plain old 0. So this just becomes the natural log of the absolute value of y equals 2/3 x to the 3/2. c is gone. Take everything to the power of e. This will be e to the 2/3 x to the 3/2. We've kind of saw this coming again. We end up with a plus or minus. We need to check this to make sure everything works. So we'll put in y of 0 will be plus or minus e to the 0 power, which is going to give us plus or minus 1, but we were only looking for only positive 1. So our final answer is going to be y equals only e to the 2/3 x raised to the 3/2 power. And now you have mastered the skill of solving differential equations by separation of variables. Enjoy doing your homework, and I will see you on Monday.